Greetings everyone. Our project is called Human Assistive Hand Robot. Our team consists of four members: Afaq Hussain, Abdul Kubar, Adarsh myself, and Dheeraj Prakash. Our supervisor is Dr. Muhammad Asif Khan. So let's start our presentation. Introduction. In the United States, every year 1.7 million people lose their limb and approximately 100,000 of them lose their limb and go through amputations. Among 10% of them are at hand or at wrist. Since a human hand is an ideal end effector, it can communicate through gesture, grasp objects, perform actions, etc. Therefore, in this project, we have developed what is called a human assistive hand robot prototype, which can mimic a finger movements and wrist roll. The result that we achieved is by using the flex sensors, which can track the joint movement and finger and perform its action to the 3D printed hand model. Methodology. So how have we achieved it? What have we used? I'm going to explain that. We have used 3D printed hand robot and used flex sensors. Some of the 3D printed files I have shown below, as you can see. So we have used approximately 29 STL files for 3D printing, and it is all an open source project from InMove. It took almost 70 plus hours for the 3D printing continuously. The center part is the flex sensor. The flex sensor is flexible sensor attached to the glove. So when a human wear the glove and clench its fingers, so the 3D printed model tries to mimic the finger movements. So the flex is attached, like I said, to the hand glove. So we have a specified varying resistance of the finger movements for upward and downward, and through this, the sender, the flex sensor, sends the movements through the Arduino Uno to the receiver, which is a 3D printed hand model. So here you can see the some pictures of a handprint model. First is the servo motor, second is the completed hand model, the receiver, and third is the sender, the glove attached flex sensors. Here you can see the circuit diagram of the sender, the flex sensor. The flex sensor attached connected to the Arduino Uno, which sends to the varying resistance to the 3D printed hand model, the receiver. And here's the servo motors are the receivers in the hand printed model. In the forearms, the servo motors are attached, and you can see here every servo motor is attached to the breadboard, which is connected to the Arduino Uno. And here you can see the full circuit, which means sender, press, receiver. Here flexes are attached to the PCB, and the PCB is attached to Arduino Uno, and Arduino Uno is attached to the servo motors. So what are we here trying to solve? What are its applications? Here, the human assisted hand robot can be used in long surgical operation, body paralysis, handling chemicals, prosthetics, bomb diffusing, and of course, research and development. So here I'm going to show you some our project demonstration videos. So let me just play it. Here you can see all the movements that is happening here of each finger in the human assistive hand robot. So let's move on to next video. So this is the actual demo that we have performed with our supervisor, Dr. Muhammad Asif Khan. So both of the video links are attached below since the videos are uploaded on YouTube. Let's move on forward. So what will be our future work? The final and remaining part of our project is waiting for the approval from the IEEE R10. So in the final stage, we will use EMG sensor to detect finger joints, angles, and the wrist. So what is an EMG sensor? EMG sensor is a small sensor which detects small electrical signals from our muscles. So this includes lifting the arm, clenching your fist, etc. So even the simplest movements like moving a finger can be tracked through the sensor and can mimic the motion of the fingers. So after embedding EMG sensor, we complete our project. Also, we will all, since this the whole project is wired, we will use Arduino Nano Glove, which will make our project connected wirelessly. So this is our whole project, and I hope that you like our project, since our team and our supervisor have worked very hard on this, and I hope that we pass the second stage of IEEE Art in Robotics competition. So that's all. Thank you very much.